Alright, count of substrings containing every vowel and K consonants part 2. This problem was in the recent weekly contest, or I think bi-weekly contest, I don't know. We are given a word and the integer K. It's a non-negative integer, and we are asked to find every substring inside this string such that the two conditions are met, and those two conditions are it should contain each vowel at least once and it should have exactly K consonants. Alright, so this is the problem, and right away if you look at the example, this is the word, then E, E, I, O, U is in this window, and then one more consonant will make this window a valid substring. Now if I try to lose all the vowels and keep this consonant, I can't really extend the window, so I'll start from here. I will continue until I find that all the vowels are there in the window, and I can't really extend because I have to have exactly consonants. So this is the another window that is valid. And now if I lose this queue, then I am able to gain this queue and find another valid substring. And that's it. There's no other valid substring that is possible. So right away, if we look at it, sliding window is very intuitive, but it can be little complex in handling those edge cases. So the other approach, which is not being used a lot in this problem, is binary search and prefix sum. So along with using these two concepts, we can solve this problem. Uh, we need to find window, right? The right window. And there are two things to a window, the starting point and the ending point. So if this is the example and k is 1, we can build a prefix sum for the vowels, and suppose this is the prefix sum. I have not completed it, but you get the idea. Then for the right window, I will need two things, right? Uh, or let me call this window. I need two things. First thing is the starting point. What should be the starting point? Well, it should have this condition, right? So it should have all the vowels at least once and have exactly K consonants. So this can be the starting point, and then the upper limit till this point, till the point where it's valid, right? That will be the ending point. So the starting point will be all vowels at least once, and K should be greater than equal to uh, the consonant count, or let me call this way: consonant count should be greater. I'm sorry, should be greater than equal to K. Why we are doing greater than equal to K? Because you'll get the idea when I talk about the ending point. Ending point should be uh, consonant count less than equal to K. So if I find this, and by the end I will say that starting point should be less than ending point, right? Only then it is going to be valid, because it might give me a greater index than this, then it's not valid. Then there is no way to form this substring, and I'll return 0, right? But if this is valid and this is valid, this gives me an index, and I will say if starting point is less than or equal to the ending point, then I can increase my answer with whatever the ending point will be minus the starting point plus 1. Okay, this will be the window. and this will be updated in my answer. And I can do the same thing for every index to find all the substrings that is possible, which will be O of n log n, which is not really optimal if you compare it with sliding window technique, but it's a good practice to know this approach as well, because there's a lot of sliding window answers out there. Let's code it up. I need the length, so word of length, and I need the prefix. So let me have prefix as this. What will be the size? So for every index, I will have a prefix sum. So n plus 1, just for the base case, I have one extra, and uh, so I need the consonant count as well, right? So if you remember, I have cleared it for some reason. I had the consonant count to be checked for the first binary search. Binary search 1 vowel uh, condition plus consonant count greater than equal to k, and similarly this should be less than equal to for the second binary search. So this is calculated using this formula, or I can have a prefix sum for that as well, but I don't really need that because if there is a window, the total number of characters inside that window minus the total number of vowels inside that window will give me what is needed, right? So I can have a total vowels prefix as well, which I can just add a character or a position here, which will give me this. So instead of having 5 vowels positions or storage, I will have six positions storage. One will be for the total vowels. So n plus 1 comma vector of n 6, right? I will traverse int I is equal to 0, I less than n, I plus plus. Vowel prefix will be having the state of its previous index. So let me copy that at least. Plus if this word of I is in the vowel. So I will have an indexing, right? That's why I have just 5 or 6 characters, 5 vowels and 1 total vowels. So for that I need a indexing for every character, which can be created here. Vowel index is equal to A will be mapped to 0. Similarly, E, E, I, O, U. So U will be mapped with 4. Uh, this will be 3. This will be I. This will be A, E, I, O. So this will be O, suppose. This will be 2. This will be E. This will be 1. Alright. So if vowel index dot find vowel, a word of I is not equal to, so if it's a prefix, then just increase the prefix. If it's a vowel, then increase the prefix of this particular index. So vowel index of word of I, right? And the fifth or the sixth or the fifth character, right? Fifth index will have the total vowel, so I will increase it in any case, right, for uh, this index, right? So now the prefix is created. I will do a binary search for every index. So let me iterate. I will do a binary search to find the start point. I can do a binary search with two different functions, or I can just have a choice for if I want to have that as a single function. Let's so for this binary search, I'll pass the starting index, uh, the vowel prefix for sure. Uh, I think that's about it, and key, right? And the choice if this is a binary search for the starting index or the ending index. So for the ending index, I give the choice as 1, and this will be the condition that if start is greater than equal to, so whatever I get from here should be less than equal to the end, only then it's a valid scenario. I'll add this up in my answer, which will be long initialized with 0, answer plus equal to end minus equal to start, sorry, not minus start plus 1, and that's it. This might overflow, so let me fix that. The binary search will return an index, so that is not going to overflow. The start index or the index, I'll call that vector of end, passed with reference vowel prefix end k and end choice. Uh, so the starting will be the index itself. The ending will be n or n minus 1, right? The ending will be n minus 1, but that I have not passed, but I can extract that out from this because it's n plus 1. So this will be n and this will be n minus 1. Okay, and my answer initially will be for the binary search where I find the starting point. In that case, the answer should be initially the ending, right? So it should be based on choice. So if choice is equal to 0, which means I want the first point, so my answer will be last, right? So last will be vowel prefix dot size. Let me extract this out. So I'll be using this thing 2 times. So this will be n. So this will be n minus 1. This will be n, and this will be, if choice is 1, then I'm finding the end point. So I should fix answer as the start. Minus 1 will be better so that I don't interfere with the answer. When start is less than equal to end, I'll get the middle as start plus n by 2, and if at this point choice is 0, then I will be trying to find the condition, vowel condition. So for that I will have to check the count of every vowel in the window, if it is equal to 0 or not. If it is 0, then it's an invalid case and I should go towards right. If it's not 0, all of them are 1, then I will check for this particular consonant count. If it is greater than equal to k, in that case both are valid, then I will go towards left. Otherwise I will go towards right. Alright, so I will have a valid will be initially true. I will iterate through all the vowels index. So I will check if the vowel count, which is nothing but uh, vowel prefix mid plus one. Why I'm doing plus one? Uh, because I have in my prefix one extra position for the handling base case of I minus vowel prefix of index. I'm not choosing start, but I'm choosing index because that's the starting point, right? That's a window. So, so my starting point of the window is fixed from here itself. Alright. And I, so vowel count, if it's equal to 0, in that case, valid is equal to false and break. If valid and the consonant count, so I will get the consonant count. How will I get it? Well, what is the window? Window is mid plus 1 and index. So mid plus 1 minus index is the total number of elements plus 1. So this is J minus I plus 1, right? That's how we calculate the total number of elements within a window. Minus the vowel count. Well, this is the vowel count. I can reuse this, copy paste it here, do the same thing. Now I have consonant count. Well, if consonant count is greater than equal to k, then go towards left. So end is equal to mid minus 1. Before going towards left, give me my answer. Uh, is equal to mid. Else go towards right, which is start is equal to mid plus 1. Else, if the choice is 1, then I am going to do the same thing, just opposite. So consonant count is what I calculate, and if it is less than equal to k, since this is the endpoint, I will go towards left and otherwise towards right. So essentially this is opposite. I don't have anything called valid, and this is less than equal. That's it. And here I return answer. That's pretty much it. Let's see if this works. I don't know why if it's alright. So vowel prefix is vowel prefix. Sorry, vowel prefix. Let's be careful of the spellings. Okay, there is nothing called I. My bad. So this is the total number of elements, and this is the total number of vowels, which is calculated by this part, right? This is the total number of vowels for a particular index. So within a window, I will do this. Alright, let's do this here as well. And now let's run it. Alright, the mistake that I did was this should not be mid plus 1, it should be mid for the consonant count, because this is the total number of elements, and that is nothing but j minus I plus 1. So this is the fixed mid or the endpoint. But here it should be mid plus 1 because that's how we calculate vowel prefix. We have one extra for the edge case, and that's why I made plus one. So that's the mistake, and let's see if this works now. Space complexity will be O of 1, or actually O of n, actually O of 5n, because for every index I have 5, or actually 6 indexes stored, and the time complexity will be 2 binary searches, so not one within another, so it's basically 2 log n, so essentially n log n for every index. Since we are doing 2 binary searches, it will be n log n, and that's it. That's the problem. Thanks.